The Fujita scale, or Fujita-Pearson scale, is a scale for rating tornado intensity, based primarily on the damage tornadoes inflict on human-built structures and vegetation. The official Fujita scale category is determined by meteorologists and engineers after a ground or aerial damage survey, or both, and depending on the circumstances, ground-swirl patterns, weather radar data, witness testimonies, media reports and damage imagery, as well as photogrammetry or videogrammetry if motion picture recording is available. The F scale was replaced with the Enhanced Fujita scale in the United States in February 2007. Background: the scale was introduced in 1971 by Tetsuya Fujita of the University of Chicago in collaboration with Alan Pearson, head of the National Severe Storms Forecast Center and SSFC. The scale was updated in 1973, taking into account path length and width. In the United States, starting in 1973, tornadoes were rated soon after occurrence. The Fujita scale was applied retroactively to tornadoes reported between 1950 and 1972 in the National Oceanic and Atmospheric Administration National Tornado Database. Fujita rated tornadoes from 1916 to 1992, and Tom Grazialis of the Tornado Project retroactively rated all known significant tornadoes in the U.S. back to 1880. The Fujita scale was adopted in most areas outside of Great Britain. In 2007, the Fujita scale was updated, and the Enhanced Fujita scale was introduced in the United States. The new scale more accurately matches wind speeds to the severity of damage caused by the tornado. Though each damage level is associated with the wind speed, the Fujita scale is effectively a damage scale, and the wind speeds associated with the damage listed aren't rigorously verified. The Enhanced Fujita scale was formulated due to research which suggested that the wind speeds required to inflict damage by intense tornadoes on the Fujita scale are greatly overestimated. A process of expert elicitation with top engineers and meteorologists resulted in the F-scale wind speeds. However, these are biased to United States construction practices. The F-scale also improved damage parameter descriptions. Derivation: the original scale as derived by Fujita was a theoretical 13-level scale designed to smoothly connect the Beaufort scale and the Mach number scale. F1 corresponds to the 12th level of the Beaufort scale, and F12 corresponds to Mach number 1.0. F0 was placed at a position specifying no damage, in analogy to how the Beaufort's 0th level specifies little to no wind. For these wind speed numbers, qualitative descriptions of damage were made for each category of the Fujita scale, and then these descriptions were used to classify tornadoes. The diagram on the right illustrates the relationship between the Beaufort, Fujita, and Mach number scales. At the time Fujita derived the scale, little information was available on damage caused by wind, so the original scale presented little more than educated guesses at wind speed ranges for specific tiers of damage. Fujita intended that only FOF5 be used in practice, as this covered all possible levels of damage to frame homes as well as the expected estimated bounds of wind speeds. He did, however, add a description for F6, which he phrased as inconceivable tornado, to allow for wind speeds exceeding F5 and for possible future advancements in damage analysis which might show it. Furthermore, the original wind speed numbers have since been found to be higher than the actual wind speeds required to incur the damage described at each category. The error manifests itself to an increasing degree as the category increases, especially in the range of F3 through F5. NOAA notes that precise wind speed numbers are actually guesses and have never been scientifically verified. Different wind speeds may cause similar-looking damage from place to place, even from building to building, without a thorough engineering analysis of tornado damage in any event. The actual wind speeds needed to cause that damage are unknown. Since then, the Enhanced Fujita scale has been created using better wind estimates by engineers and meteorologists. Some sources add level F+, meaning a tornado with winds below 39 miles per hour. On rare occasions, tornadoes this week are observed covering a wide range of path widths and lengths. Parameters. The 5 categories are listed here, in order of increasing intensity. Where the relative frequency of tornadoes is mentioned, it is the relative frequency in the United States, for which the best data exists. Strong tornadoes occur less often elsewhere in the world. The ratio seems to be similar except for some areas where it's less, such as the United Kingdom. But because of few overall number of tornadoes, there are few strong tornadoes. Areas of eastern India, and possibly a few other areas, to have frequent severe tornadoes. However, data are scarce and statistics in these countries have not been studied thoroughly. The rating of any given tornado is of the most severe damage to any well-built frame home, a comparable level of damage from engineering analysis of other damage. Fujita's initial wind speed estimates have since been found to be highly inaccurate. See Enhanced Fujita scale. Since the Fujita scale is based on the severity of damage resulting from high winds, an F6 tornado is a theoretical construct. Structural damage cannot exceed total destruction, which constitutes an F5. Rating classifications. For purposes such as tornado climatology studies, Fujita scale ratings may be grouped into classes. Decommission in the U.S. The Fujita scale, introduced in 1971 as a means to differentiate tornado intensity and path area, assigned wind speeds to damage that were, at best, educated guesses. Fujita and others recognized this immediately, and intensive engineering analysis was conducted through the rest of the 1970s. This research, as well as subsequent research, showed that tornado wind speeds required to inflict the described damage were actually much lower than the F scale indicated, particularly for the upper categories. Also, although the scale gave general descriptions for the type of damage a tornado could cause, it gave little leeway for strength of construction and other factors that might cause a building to receive higher damage at lower wind speeds. Fujita tried to address these problems somewhat in 1992 with the modified Fujita scale, but by then he was semi-retired and the National Weather Service was not in a position for the undertaking of updating to an entirely new scale, so it went largely unenacted. In the United States, on February 1, 2007, the Fujita scale was decommissioned in favor of what these scientists believe is a more accurate Enhanced Fujita scale, which replaces it. The meteorologists and engineers who designed the F scale believe it an improvement on the F scale on many counts. It accounts for different degrees of damage that occur with different types of structures, both man-made and natural. The expanded and refined damage indicators and degrees of damage standardize what was somewhat ambiguous. It also is thought to provide a much better estimate for wind speeds, and sets no upper limit on the wind speeds for the strongest level, EF5. Several countries continue to use the original Fujita scale. Environment Canada has begun using the Enhanced Fujita scale in Canada as of April 18, 2013.